Yes, sir.
So in the previous class, we had started the preparation of ether. So basically, I'm going to start from here. We started ether. We already completed the nomenclature of ether and the structure. So first of all, preparation of ether. Preparation of ethers. So how do we prepare ether? There are different methods, and the first one is basically by dehydration of alcohol. By dehydration of alcohols. And as you know that when alcohol is dehydrated, first we learn that by dehydration of alcohol we get alkene. But here you can see by dehydration of alcohol we will get ether. So how we are going to get it? Basically, if there is an alcohol, that is ethanol, CH3 CH2OH. And there are two conditions. If you will go condition from condition 1, basically H2SO4, and the temperature is 443 Kelvin, and if you are going to react this with a reagent H2SO4 at its temperature 413 Kelvin, you can see the difference in temperature is 30 degrees centigrade. So here you will get CH2 double bond CH2, and here you will get CH3 CH2O CH2CH3. That means basically you have to be careful about reagent and the condition. If the same reactant reacting with the reagent H2SO4 at 443 Kelvin, you will get an alkene. And if you are going to react the same reactant with the reagent, same reagent, but the temperature, the condition is 413 Kelvin, then you will get an ether, that is basically ethoxyethane. Ethoxyethane. So what is the mechanism behind it? The mechanism for this we have already studied, that there will be removal of water. Now, what is the mechanism behind the dehydration of alcohol and getting an ether? We will see about it. So I think you have written it in the previous class, right? Everyone, Madiha, Rim, and Ayman.
Yes, sir.
Okay. So I'm moving towards the mechanism. What is the mechanism behind it? So it's a very simple mechanism to understand. There are 3 steps in the mechanism, in this mechanism. The first step is basically this alcohol, that means ethanol, will be protonated alcohol. That means we are going to react this CH3 CH2 OH with H plus, that means proton. Then what we are getting is very important to know. You know that O has more electron, that means electron rich species, and H plus proton, that means it has no electron. So it will attack this and it will make a bond like this, CH3 CH2, and then O, and then H, and then H, and there will be positive charge because oxygen donated one of its electron. Now see what will happen in the second step. It's very easy to understand. Again, this ethanol will react with this protonated alcohol. So I'm going to take this ethanol CH3 CH2 OH. That means you can see this is the OH. I'm going to show you, and you can see this is CH3, this protonated alcohol, CH2, and you can see O, and there is 2H, and on oxygen there is positive charge. And I have told you so many times that positive charge on the oxygen is less stable. And I already told you in the previous chapters also that on more electron negative element, positive charge is less stable and negative charge is more stable, and vice versa. If element is more electronegative, negative charge will be stable. If element is very less electronegative, that on that positive charge will be stable. Now, in order to stabilize oxygen itself, what oxygen will do? It will take electron from carbon. It will take electron from carbon and it will be eliminated or remove H2. It will eliminate it, become H2 and it will be removed. Now you can see there will be deficiency on carbon. There will be deficiency of electron on carbon and that oxygen will see and attack on this carbon. Now see, I will write this part first. So there will be CH3, CH2, and then O, and I'm going to erase this. I will write it later. O, and then with O there is H, and now since oxygen donated its electron to this carbon, so it will be CH2 and then CH3, and since oxygen is has donated one of its electrons, so it will have positive charge again. Is that clear? The second step, all of you?
Yes, sir.
Now see, again, oxygen has positive charge. That means it is less stable. So in order to stabilize itself, what oxygen will do? It's very easy to understand. You can see this is the scenario. This is the scenario. Now what oxygen will do? It will take electron from hydrogen to stabilize itself. Now you will see that you will get CH3, CH2, and since oxygen accepted or attracted or withdraw electron from hydrogen, it will be now neutral because it has already positive charge. Since it takes electrons from hydrogen, there will be negative charge, positive, negative, neutral, CH2, CH3, and this H plus will be eliminated. Now you can see the H plus that you used in the first step will be eliminated in the last step. So this is the mechanism behind the formation of ether by dehydration of alcohol. The difference is that when you are going to dehydrate an alcohol and you are going to take only 1 mole of ethanol at 443 Kelvin, you will get an alkene. But here you can see you are going to take 2 mole of ethanol and the temperature should be 413 Kelvin concentrated H2SO4. Here we use the first ethanol, then got got a protonated alcohol, and this protonated alcohol again will be reacting with 1 more mole of ethanol, and then you will get this, and then in order to stabilize itself oxygen, it will take electron from hydrogen, and now hydrogen will become proton. So this is the mechanism behind it, which is very easy to understand. Please let me know when you are done with this.
So, sir, this is the mechanism for what state, sir?
Okay, everyone done with this?
Done, sir.
Okay. Now see, it's very important to know that this method, just write a point with me, you will get it easily. Or you can write the method is suitable for the preparation of ethers having primary alkyl groups. Primary alkyl groups, not secondary and tertiary. Only. Just write only this. Primary. And then write the next process or method, that is Williamson synthesis. Please do write it. Let me know when you are done with this writing, and then I will explain what is Williamson synthesis reaction. It is also known as name reaction, which is very important. And basically, it is a laboratory preparation or laboratory method. We can prepare ether in laboratory. Everyone done with this point? I'm in Reem.
Done, sir.
Very good. Now see, what is this Williamson synthesis reaction? It's very easy. Basically, from this, we can prepare symmetrical as well as asymmetrical ether. Symmetrical as well as asymmetrical. Or symmetrical ethers. Now you can see that symmetrical and asymmetrical ether. Basically, if there is an alkyl halide and going to react with sodium alkoxide. Sodium alkoxide, that means basically there will be alkyl group connected with oxygen and sodium like this. And there will be, you can write negative charge and here positive charge. Now what will happen? It's very easy to understand that. You know that this will have negative charge and this will have positive charge, since this halide or halogen is more electronegative than carbon. And what you need to do is just easy. This negative will go with positive. So R O R, just take it R dash or R, whatever you want to take, and there will be elimination of salt. So if I'm going to take an example, if you have CH3 CH2Cl and if you have CH3O Na, so there might be negative charge or positive charge, or there might not be negative or positive. So you can see chlorine is negative, electron negative, so negative, and here it is positive. So this will go here and this will go with this. So it's very easy to understand. I'm going to write this first, CH3 and then O. With O, who is coming? CH2. And with CH2, what is associated? CH3. And along with, there is a byproduct, that is salt, sodium chloride. So basically this has a name, that is sodium alkoxide. Sodium alkoxide. And if there was phenol, that will be known as a benzene connected, that will be known as sodium phenols. Please do write. Let me know when you are done with this.
Done, sir.
Very good. So if I'm going to give you a reaction on this, if you have CH3 and then quinine, and you are going to react this with CH3 CH2. Dear, can you tell me the product? Please do this reaction. Are you done with this? Rim, Ayman, Madhya. Madhya, is there any answer for this question? Aman, am I audible?
Yes, sir.
Rim,
Yes, sir.
please do let me know if you have any doubt or anything. Am I audible clearly? Ayman and Rim.
Yes, sir. Now you are.
Madiha, might
Yes,
be
sir.
your net is weak. Madiha, am I audible now? Clear to you? No, sir. So my Rim, can you hear me clearly?
Yes, sir.
Okay, Madiha, you should. My voice is lagging, but only for you, Madiha. Might be your, maybe your internet connection is weak. So see, it's very easy question. You don't need to think too much. This is negative, this is positive, this is positive, this is negative. Now what you need to do? Just make it clear. CH3 there was, I'm going to write this first, then CH, and then you can see O, and then here it was CH3, and O will be connected with this CH2, and CH2 is basically with CH. This bond will be broken. This bond will also be wait a minute, not this, between this, and then Na will combine with Br and forms NaBr. It's so easy. I mean, what is the problem? Where is the problem?
So how do we identify negative and
Positive. That's a very good question, but you should know. Can you tell me if I'm going to write CH3, CH2, Br? You know that this is basically hydrogen, hydrogen everywhere, hydrogen, then hydrogen, hydrogen, and Br. Now, can you tell me between this and this carbon, on which positive and negative comes? 0, 0, neutral, because they are same carbon, they are same element with the same hybridization. So whatever is the electronegativity of this carbon, same electronegativity of this carbon, that means 0. Now come to this carbon and bromine. Bromine is more electronegative than carbon, yes or no?
Yes, sir.
So it
Yes,
will
sir.
attract carbon's electrons, so it will have delta negative or it will have delta positive. Now come to this O and Na. Sodium is metal, electropositive, that's why plus. Oxygen is non-metal, second most electronegative element in the periodic table, that's why negative. So please write.
Done.
So please let me know, are you done with this, Aman? Okay, thank you. Now see, it's very important. I'm going to give you 2 questions, and it's very important. You should do it on your own, and I will explain the mechanism behind it. Vitamin and most probably there will be written positive and negative, and there cannot be written. There may not be written, but you know this. There will be positive and negative. Please write the product. Please write. Can you do this?
Yes, sir.
Rim and
Yes, sir.
okay. Ayman. Ayman, are you done with this?
Sir, yes, with the first one.
Please do the second one. Madhya and Rim.
Only the front, sir.
What you just said, are you done with the second one also?
Sir, the only difference is that the functional groups are switched, sir, right?
Yes. If the functional group switches, that means the compound is different, right?
Yes, sir.
And if the compound is different, the product will be different. Should I explain? Rim.
Yes, sir.
See, it's very easy. So have you done like this? This is negative, this is positive. So this positive will go to this. And I'm going to write this part first. So it will be CH3. The rest part will be same. It will be CH3 and then CH3 and then O and then CH3, right? And this will go with this.
Yes, sir.
Product will be NaBr. Ayman, is it correct for you also?
Yes, sir.
Now see, if you are going to do this, so this positive will go to this, and this positive will go to this. So you can see I'm going to write this part first. Is 3 O. Wait a minute. CH3C, CH3, and then CH3, and then OCH3, and then NaBH. Have you got this? I mean,
Yes.
if you got this, this is wrong. This is wrong. Always remember, if alkyl halide is primary, then ether can easily form. But if your alkyl halide is 2°, that means secondary or tertiary, then elimination competes over substitution. Elimination competes over substitution. Elimination competes over substitution. Wait a minute. Elimination competes over substitution. And alkene will form. Alkene will form. It's very easy to understand. What you need to keep in mind is that here Br or alkyl halide was primary. If alkyl halide was primary, that is easy, that is okay, and then ether will form. But if alkyl halide is tertiary or secondary, then elimination will compete over substitution, and then alkene will form. Now you can see that if you have this reactant CH3C, CH3, and then there will be CH3 and then Br. This reaction again I'm going to write CH3 and then O and then Na, and you know that there will be metal positive and there negative. Then the product is basically what? The product, what I told you is there will be elimination, and whenever elimination takes place, double bond will be formed generally. So double bond will form like this: CH3, C double bond, CH2, and then here it will be CH3 along with NaBr and CH3OH along with CH3OH. That means alcohol. First, you are going to write this wrong, and then here you are going to write elimination competes over substitution when alkyl halide is 2° or 3°, and due to elimination, this alkene will form in this way. Now I am going to explain how does this alkene forms, which is very easy to understand. So first of all, you are going to write it, then I will explain the reaction one by one, step by step. Let me know when you are done with this. I'm ready. Madiha, are you there?
Yes, sir.
So please write it and let me know if you have any doubt.
No, sir, I'm done.
Rim, are you done with this?
Almost.
Okay, take your time.
Done, sir.
Madhya. So always remember, Madhya, that whenever tertiary alkyl or secondary alkyl will be reacting with sodium alkoxide, then elimination will compete over substitution and your alkene will be formed. Madhya, can I change the slide?
Yes, sir, you can.
Okay. So how does this reaction takes place? So see, I'm going to explain. First of all, Br will take electron from this carbon. So there will be the formation of carbocation. There will be formation of carbocation like this. You can see there is CH3 and there is CH3. And this Br will go with sodium and it will form NaBr. This will go with sodium and NaBr. Now this will have CH3 O negative. Okay. Now what happened? In order to satisfy itself, carbocation will, what carbocation will do? You can see this is hydrogen. So basically this carbon or this carbon or this carbon, whichever is directly connected to this carbon, will take one electron from hydrogen, and hydrogen will be eliminated with H plus, and this H plus will come with this, and then CH3OH, that means methanol, and NaBr is already formed. Now you can see, since this carbon is taken electron from this, so what it will be, basically CH3C plus, I'm going to write here CH3, and there will be CH2 minus, CH2 minus. So what it will do, it will donate electron to this carbon and make double bond. So in this way, elimination competes over substitution and forms alkene. Ayman, did you get it? Do you get it?
Sir, no, not about the part of the hydrogen.
Okay, wait a minute, I'm going to write again. So Ayman, basically we have CH3. This is CBr and there is CH3. And can I write here CH3 as CH2H? Can I write this?
Yes, sir.
Now we have basically CH3O negative and there is Na plus. Now what will happen? Bromine is more electronegative than carbon. It will be eliminated. And you can see this has a negative charge. So bromine will go with sodium and it will be eliminated as a byproduct and forms NaBr. Is that clear?
Yes.
Now see what left in the reaction. What left in the reaction? There will be carbocation because bromine took electron from this carbon and all are same like this. And since Na plus is eliminated from this part, so it will be left with CH3O minus. Are you getting my point?
Yes, sir.
Now, in order to satisfy this carbon itself, what this carbon will help. How? Carbon will take electron from hydrogen. So this hydrogen will be in the form of H plus. So this plus will go to this part. Are you getting my point?
Okay, sir.
So this part will be becoming alcohol CH3OH and eliminate. Now what we have left with, this is basically CH3 and then C, and there is CH3 and there is positive charge and there is CH2 minus. Is that clear?
Yes.
Now, what can I write this CH3 here instead of writing on the bottom?
Yes, sir.
Now, do you know one negative charge, that means 2 electrons? So it will donate 1 electrons to this carbon. So it has positive charge already, and since this carbon is donating one of its electron to this carbon, it will have negative, and positive negative will cancel each other, and there will be the formation of double bond. There will be the formation of double bond like the CH3, C double bond CH2, and then CH. Are you getting my point now?
Okay, sir.
Or you can directly write like this. That shows hydrogen will be eliminated and this bond will shift to this, and there will be like this. Are you getting my point now?
Yes, sir.
So please write it if you want it. Then I'm going to give you a question. This is very important. Then we'll move to the phenol side. Let me know when you are done with this. Ayman, are you done with this?
Yes, sir.
Okay. Now I'm going to give you a question. Madiha,
Yes, sir.
please do the question. The following is not an appropriate reaction. For the preparation of tertiary butyl ethyl ether, tertiary butyl ethyl ether. The reaction is basically given C2H5ONA. Whatever I just taught you, it is based upon that. And this is CH3, and this is CH3. And the reaction is given as CH3, this is C, and then O, C2H5. This is CH3, and then CH. The first question is basically what would be the major product of this reaction? Major product of this reaction. And second is write a suitable reaction for the preparation of tertiary butyl ether, tertiary butyl ethyl ether. Basically, this for the preparation of this. Please do this carefully. It's a very good question. Very good. Madhya, very good. Very good, Madhya. Thank you. Ayman, what about you?
So I can't follow the second answer.
The first one, what is the answer for the first one? See, whenever an alkoxide will be reacting with tertiary alkyl halide, then whatever is here, that is that will become alcohol, and this part will become CH3CH, double bond CH2, and then CH3. Elimination will complete over substitution, and the product name will be 1, 2, 3. So the product IUPAC name will be 2-methyl prop 1 E for propane. Are you getting? Are you getting my point?
Yes, sir.
Now see, in order to make this or prepare this, what do you need to do? It's very simple. CH3C. We are going to take alkoxide part with tertiary and primary part with alkyl halide. That will be basically C2H5C. We just change the position of this halide and alkoxide part, and then you are going to write negative, and there will be positive, and there will be positive, and there will be negative, and this part will be connected with this. So it will be CH3 and then C and then O, CH3 and then CH3 and then C2H5. Got it? Ayman,
Yes, sir. I'm copying it now.
please try it. Aman, are you done with this?
Yes, sir.
Okay. Now we just studied how to prepare alkoxide. Phenoxide prepared in the same way. It's very easy. So write a point. Phenols are also converted to ethers by this method. So basically, if you have phenol, this is your phenol, and you are going to react this with NaOH. Then what will happen? It's very simple. This is acid, this is base. So basically, we have already have seen the reaction. There will be negative phenoxide ion, and then this will react with RH. First, we will make it phenoxide ion, and then there will be negative, there will be positive, and NH will be eliminated. Please write. Are you done with this?
Yes, sir.
Nadia?
Yes, sir.
Now see the chemical reaction. I haven't taught you the physical properties. I have only taught you the chemical properties. At the end of this chapter, we will discuss about the physical properties also. So the chemical reaction also is of two types. Here, cleavage of CO bond. Cleavage of CO bond in ethers. Here you can see if you have an ether ROR that will react with hydrogen halides, then the product will be alkyl halide along with alcohol. It's very simple to understand in the same way that we are doing the reaction. This will be positive, this will be negative, this will be negative, this will be positive, and just add positive, negative, negative, positive. Now again, ROH, if you are going to take hydrogen halides in excess, this alcohol will react with this alkyl halide in the same way. Like oxygen will have negative charge, alkyl group will have positive charge, then again positive and negative, and then you will get Rx again, another mole of alkyl halide with the removal of water. So please do write it. And if I'm going to give you a reaction like this, please do this. CH3, CH2, O, CH3. Reacting with HI. Please let me know the product. Are you done with this? Madhya, Aman?
Yes, Ramda.
So it's very easy. There will be negative, there will be positive. There will be negative, and there will be positive. Wait a minute. Okay, just break it and you will get first alcohol. And then you will get an alkyl halide. Again, you can do this also. There will be positive, there will be negative. Then you will get CH3, CH2I. All the product I am writing, and then CH3OH. Please do write it. Have you got the same?
Yes, sir.
Negative, positive can be here and here, positive, positive. Let me know when you are done with this.
Yes, I'm done.
Now see, you can do this reaction easily. If you are unable to do it, please let me know. If you have given this 4 and you are going to react this questions, please let me know the product. Can you do this? See, it's very simple. This will have negative, this will have positive, this will have positive, this will have negative. So you will get a phenol OH and RX. Are you getting my point? Aman?
Okay, sir.
So if I'm going to give you, don't make it positive there, because positive on benzene is very unstable. Phenyl cation. Please let me know.
Yes, sir. I'm done.
Are you done with this? I mean,
Yes, sir.
so this is what you get. What
So
phenol,
we get OH, alcohol, phenol.
phenol, and then there will be CH3, CH2, right?
Yes, sir.
Very good.
Yes, sir.
Can I move to the next part? Can I change the slide?
Yes, sir.
Okay. Now, asymmetrical ether can also be react in this way. Asymmetrical ethers can also be claimed in the same manner. See, if you have ROR dash that reacting with hydrogen halide, it's very simple. You will get RX. You will get basically total 4 4. I'm going to write 2 4 R dash. Now, order of reactivity is very important to know. Order of reactivity of hydrogen halides is basically iodine is the best living group. That's why hydrogen iodide, then hydrogen bromide, and then hydrogen chloride. Please write. Are you done with this? I mean, Aman, are you done with this?